We are live. Hello, welcome, good morning, afternoon, evening, night, whichever the case may be, to Bridgepoint's new channel and the first of several, hopefully very many, lunch and learns where we cover a whole wide variety of different topics. Today, I've got with me a guest speaker that's going to help with the presentation, a nice guy by the name of Chris Ehlers. Most of you at Bridgepoint know him. You've worked with him. He's been off in contract for some years. So you might haven't seen him recently, but he's helping us out today, doing it remotely because, social distancing. Thanks in advance for taking the time out of your day. On that note, I think we are going to dive right on in. Today's Lunch and Learn is going to be on the topic of discriminated unions, which is a software topic that's kind of my forte. So that's when I'm giving these presentations, you guys are stuck with something like that. Discriminated unions are it's a data type. So basically it's a thing that represents something else in a piece of software. So this particular thing, this data type, is something that describes a union of other data types. It contains one of several different things. Only one, but it could be one of several different things. So like, say I have a pocket that can fit one piece of fruit. Whether that's a banana or an apple or an orange, doesn't matter. I can only put one of those three in the pocket. And I only have room for one thing in the pocket. And I know that a lot of people aren't really well versed on software and development, and we love to get technical and use our fancy terms. So just to start with some ground rules, we'll cover what a data type is real quick. So a data type is a means of defining the possible values of a piece of data. So you've got this something, whether it's A or 1 or Rumpelstiltskin, you've got this something. What kind of something is it? That's what a data type is. It describes what kind. So here's some good examples of data types. Good numbers, 1, 2, 3, 14, 42. With letters, A, B, Q, R, so on and so forth. Words, like cow, now, brown cow. Those are 4 words. It's a different kind of data type. And items with properties. Like these are typically more complicated things, like a smartphone. It's got different properties. It's got a screen, it's got buttons, it's got a case mostly, it's got a color, it's got a battery size. And then we can also create lists of the things above. Like maybe I don't have one smartphone, I've got 10 of them. So I can define a particular data type that says, here's some random number of items. And of course, we're developers and we require precision because computers are very, very picky. So we can't just call them, typically we don't just call them numbers, letters, words, items, or properties. We've got technical terminology for all this. So numbers become integers, decimals, floats, doubles, singles, bytes, things like that. Letters turn into characters, typically abbreviated just char, C-H-A-R. Words, well, the name for that's actually pretty universal. We just call them strings. And it can be a whole sentence, a whole paragraph, an entire book. The size really doesn't matter unless there's something specific to a particular environment that causes the problem. Items with properties, those are typically structures, records, objects, classes, things of that nature. And then referring to the lists, we've got arrays. We actually do call them lists sometimes. We've got queues, we've got bags, we've got hash tables, we've got concurrent bags, hash sets. There's probably about 10 or 15,000 different kinds of lists that we can build, each with different little subtleties and disadvantages and advantages, or strangeness and quirks and all the good, wonderful things that you see in human build constructions. Whoop, and of course I hit my stupid mouse wheel. One of the rules about data types is you can't mix them. And this kind of makes sense. I mean, the letter A isn't an integer. Whatever, it's not a character. The number 6.28 is not a string. Technically, you can have a string that holds 6.28, but it's holding them as if they were letters, not well defined as a number. Cats aren't dogs. And so you can't mix one kind of object with another object. And this is kind of where discriminated unions come into their own. Is a discriminated union is a way of defining a data type that holds other data types. So it's a way of grouping things that might not be related on their own together for whatever the particular needs of the project are. Which probably brings a question up right off the bat, and that is if I can create complex things, like I can create an object with all these different properties, why do I need a discriminated union? Why can't I just build what I need out of the complex object? And there's depending on what's going on, like the particulars of your real world thing that you're trying to get done, that might be possible, but it might not. Or it is, but it's a lot of extra work. And that's where discriminated unions come into play. And I figure the best way to sort of cover the advantages of that would be to actually walk through a real world example. And this is where Chris Ehlers actually comes into play. I gave the real world example to him. He didn't know what he was doing. I just said, build me a blank. I gave him his marching orders. They were create a mock payment processor that can handle checks, debit, and credit cards. The good news is it's a mock payment processor, so he doesn't actually have to do anything. Just give me the details. So at this point, I think I will hand things over to Chris.
All right, thanks, Rob. Yeah, you nailed it there. I just had basically those vague instructions to create a mock payment processor that can handle checks, credit card payments, and debit card payments. So first thing I thought was I'll just create a check class, and I was thinking of aspects of the check. Uh, Obviously, it has a account number, routing number, and amount. And one of the things that we need to think about when we're defining variables is the data types, as we were talking about earlier. Normally, you would think account numbers and routing numbers would be some kind of numeric type, but since it is legit that they can start with a 0, we decided to go with a string. All right, so this was basically a simple check class. Can you go to the next slide? Then I created a credit class, which had the credit number, expiration date, which is a date time. Same thing there with the number. It can start with a 0, so I had it be a string. TVC, which is that 3-digit code on the back, and then, of course, the actual amount of the credit. And then next slide. And then third, another class for debit, which also has number, expiration date. This time you need a PIN and an amount. Next slide. So then I decided to create a function that would accept a credit object and then process it. And since this was a mock processor, that's all I did. And then created a new function for processing debit that receives the debit object. And then next slide, same thing for processing a check. And that was basically the extent of what I did, and passed it back on to Rob, and he's going to show how this relates to discriminated unions.
Yeah, kind of, sort of. For those who are somewhat familiar with C Sharp, there's ways we can optimize and change this a bit. So the first thing we've got here is we can sort of simplify the declaration of the payment processor rather than having to remember wherever we're using this in the app to call process credit or process debit or process check. You can change it up so that you just call process in all cases and it'll figure out the right thing to do depending on what you're giving it. We take this a step further, you can notice that we should be able to further simplify the payment processor by doing a C sharp thing called building an interface. And So here's our interface. We define a payment method. One thing we had in common among all the different types, the check, the credit card, the debit card, was an account number. So we'll go ahead and put that in the interface. And then we also define a payment method as some sort of external thing that's basically just a list, so that we can say this kind of payment method is a check, this kind of payment method is a credit card, and this kind of payment method is a debit card. And what that ends up doing is when we go back to our definitions for the check, the credit card, and the debit card, we need to change them up a little bit to include this. So our check changes slightly. We just declare that it implements this interface. It is part of the iPayment method thing. And then we define its method as check. Likewise, credit undergoes a similar transformation. Make it part of a payment method, and then add the definition for credit. And same thing with debit. We just add the little bits to make it fall into place. On the other side of things, in the payment processor, this is where the change really becomes apparent, because now instead of having 3 separate declarations, one for each thing, you can bundle this together. Now we just have a single process payment method that is smart enough to change up what it's doing based on the kind of payment method we're dealing with. And where this really starts to give you gains on what you're doing is when you're processing payments or doing a lot of other things, there's bits of payment processing that are unique to checks. They're unique to credit cards. They're unique to debit cards. But there are also things to do with payment processing that are the same regardless of which payment method is used. Like, we're always going to want to log the fact that we processed a payment or handle anything that might have gone wrong, things like that. Doing it this way simplifies the application slightly, because now all of those bits that are the same regardless of all payment methods only have to be written once and maintained in this one place. And this is actually where discriminated unions can take us a little bit further. Because, and this is for those who've been watching along for a while, we've sort of been doing these lunch and learns in a less public capacity internally. And one of the recurring themes is software developers are lazy. We're not lazy in the sense that we don't want to get things done. We're lazy in the sense that we want to be efficient about what we want to do, because we hate wasting time. So anything we can do to get the software to do things for us helps us immensely. This is the sort of thing that we strive to find and capitalize on. Discriminated unions help by giving us a way to define a single thing to work with checks, with debit cards, and with credit cards without having to go through the trouble of building and linking everything to an interface. We can get all the benefits without any of the cost. So, fair warning at this point for those who are versed in software and .NET development and things like that, we're switching languages. The discriminated unions are not properly supported in C#. You can kind of get away with it. It's a bit hacky. If somebody's curious, reach out to me afterwards and I can set you up with some examples of ways to do something like it, but it's not going to be nearly as clean. So we're switching to F#, which is a different .NET language that can accommodate proper discriminated unions. So just to get everything on the same page, let's go back to our data classes, our data types, the check, the credit card, and the debit card. We don't need the interface anymore. So when we convert check over, we just revert back to the individual bits. And the same kind of transformation happens for credit and for debit. There's our 3 data types converted from C# to F#. Now, the one thing we do need to do here that's different is actually define the discriminated union. And that's going to be our payment method. It's a CC of type credit, a DC of type debit, CK of type check. These abbreviations, the CC, DC, CK, those are important because that is how we're going to refer to the various bits and pieces later. Our payment processor, which operated off of the interface, It's functionally pretty similar. It just looks slightly different. So here's our new process payment function. It's the same kind of thing. It accepts a payment amount, a payment method and amount. It makes a decision based off of that payment method and amount. And then if it's a check, it does something. If it's a credit card, it does something. And if it's a debit card, it does something. So functionally, it's not that much different. It's just we got the same thing done without having to build and maintain an interface. And this really is where future proofing applications comes into play, because we know that these days there's a ton of different payment methods. Regardless of how many we bake into the app today, tomorrow we're going to need to add a new one or new two or a new four, because I mean, let's face it, we got Google Pay, we got Apple Pay, we got Samsung Pay, it's Bitcoin, there's Dogecoin, there's money orders, blah, blah, blah. I mean, there's a whole ton of payment methods that are available these days. So to go through what you have to do to add a new payment method, we have to start by updating the enum in the C# side to add a new thing to our list. Then we have to add the actual new data type, add the new class. We have to implement the interface so that the new class participates in this system that we've built. And then we have to go back to the payment processor to implement how to actually handle dealing with the new payment type. Now, there's an implied maybe to do here, and that depending on the particulars of the payment method that you're trying to implement to add into this system, you may have to go back and change the interface. No guarantees. You might not have to. It just depends on the details of whatever you have going on at the time. To update our discriminated union example, we have to add the new type, so it's equivalent to adding the new class. That doesn't change. We have to add that type to the discriminated union so that it becomes part of the set of things we can work with. And then we have to update the payment processor, and that's it. We are done. Good to go. No more changes need to be made. F# at this point in time gets a bonus point as far as I'm concerned. This is one back to the whole point of developers are lazy. If we were to implement that new interface and class in C#, but we forgot to add it to a switch statement somewhere, nothing will tell us. We won't find it out until we go to start doing testing, and then all of a sudden something doesn't work out the way we wanted it to because it wasn't implemented over there and somebody forgot to check. In the world of F#, that gets caught by the software we use to build software. It'll warn us, hey, you're using this match statement with a payment method, but you're not matching on, like I said, say Bitcoin yet. So maybe you should add a line here that handles Bitcoin correctly. And what you do with it really depends on the needs of the situation, but the system catches this, considers it a problem, and warns you about it. And that is discriminated unions. And let's see, what do we got here? About 20 minutes flat. So I will open the floor up to questions at this point in time. If anybody wants to go ahead and chat away, I'll give you guys a couple moments while I continue to ramble on, because I know there's like a good 30, 40 some odd second lag time between what's going on here at my desk and what you guys are seeing out there in YouTubeville. And I'm pretty sure that Chris is still with us as well. I haven't received any error messages that he's gone away.
I'm
Yep,
still here.
there. Alrighty. Chris is still here. Did you have any questions, Chris, now that we've gone through it all? I mean, I know we practiced it the other day, but is there anything else you want to point out or bring up?
I actually had the internet go down in the middle of the presentation, so I got back up. But no, I think I don't have any questions. I think this is very powerful. This bonus point alone is enough to make me want to use it and also to become more familiar with F#. I'm very big in compiler warnings, so when it identifies something that needs to be improved, I really think that is a good thing.
Cool. All right. Well, looks like we don't really have too terribly many questions from the audience, so I will go ahead and let everybody get back to their lunches. And I'd like to thank everybody for taking time out of their day to watch along with us. And if you're watching after the fact, then thank you for watching as well. And we will keep this up. I think we'll be on a bi-weekly schedule for a little while, unless we make a decision to start coming up with content more frequently. But that is something that we are still in the process of figuring out. This is episode one of what I hope is a very long running and fruitful series. So, once again, I'd like to thank everybody for watching along and enjoy the rest of your morning, afternoon, evening, or night.